Good morning, good afternoon, 12 o'clock session. Thank you for taking your time to come and see our presentation. Safe passage of materials, access protection using light curtain muting. Now that wasn't the advertised title, but the content is the same. And you were probably expecting Ian Keeley-Smith to be the presenter today. Unfortunately, he's been otherwise engaged, and I'm here in his place. Seb Strutt, I'm head of product management at 6UK, and I've been in the safety business for around 24 years. I'm just looking at a colleague in the audience to confirm that. So, to onboard everybody with the topic, I've got a slide here. Safe passage of materials. What do we mean by that? Well, modern manufacturing requires a safe passage of goods between production processes, and this is increasing as production becomes more complex. I've used a very simple image of a typical application, which is a robot palletizer. Here we have an application which requires finished pallets or pallets to be depalletized, entering into a robot cell. And those points of entry that you can see around the cell obviously afford access to people. This is not an ideal situation because the robot is a hazardous piece of machinery, and we need to protect people from that situation. So typically, you would use a classic muting light curtain, and you can see one on the photograph here, protecting the access point into the robot cell using a 4-beam vertical light curtain. And those of you with good eyesight can probably see at the bottom of the light curtain there's an array of 4 sensors, and these are there to pick up the pallet moving into and out of this palletizer cell, and thereby instigate a mute of the light curtain. So the purpose of the solution is to protect people from industrial hazards, number one, allow free-flowing production at all times, that's critical to success, but must be able to differentiate between people and materials, and this is where muting becomes an awfully complicated exercise. And the term muting itself has a very clear definition, and we don't want to confuse it with terms like bypass or override, which are technically very different. Muting is defined as a temporary automatic suspension of a safety function by way of safety-related parts of a control system. It must be automatic. So, being a complex method of operating a light curtain, there are many standards and regulations pertaining to muting. Ouch. I'll walk you through this slide. I don't expect you to take it all in, but I'll point out the salient points. There are 2 types of standards relating to machinery safety. Forgive me if you know them already, but just a brief overview. A type B standard, in blue at the top of the screen, is normally a generic standard, which is applicable to all industrial machinery applications. There are also, as shown at the bottom of the slide, Type C standards, which are specific to particular machines you might be manufacturing or maintaining. The standard I've picked out, which is most succinct when we look at the requirements of muting systems, is BSEN 62064, number wang. The key points of this standard are muting must be initiated by 2 or more independent signals that are triggered by the materials moving through the light curtain or other ESPE. The muting function must be terminated as soon as any one of those signals becomes deactivated. The timing or sequence monitoring of muting signals must also be checked and maintained throughout the mute process. There must be protection against manipulation or mechanical damage to the muting sensors such that you can avoid a permanent mute situation. And this is usually achieved by time limiting the muting on the light curtain or access point to avoid a permanent mute situation. And measures must be provided to circumnavigate the ESPE. For example, if you mute a light curtain while something's going through it, there shouldn't be enough space to walk alongside the pallet or gain access alongside the object going through the light curtain. So let's look at some classic muting arrangements. I've selected 3 typical muting light curtain arrangements that you would find in palletized warehousing, storage and retrieval systems, automotive car plants. And these comprise of a light curtain and an array of muting sensors, perhaps combined with conveyor run signals, but we'll leave that for the purposes of today. There's a classic cross system where a pair of light curtains cross in front of the beam. That's a rudimentary, low-cost, entry-level muting solution. Slightly problematic, but I'll talk about that in a minute. Or parallel beam entry-exit systems, and the one here is got 2 sets of parallel beams either side of the light curtain. This allows a pallet to move both into and out of the light curtain. It's bidirectional. The middle example shows a unidirectional muting system where the pallet breaks 2 beams and enters the hazardous area. And just below are some in bottom left, right, are out-of-the-box solutions that you can purchase that fulfill that functionality. Diving a bit deeper into how they work, and I've used the cross-beam system here to highlight strengths and weaknesses. Sensor A and sensor 1 are in a cross configuration across the conveyor. The pallet, the orange box, will arrive at those 2 sensors and trigger them concurrently. And this concurrence check is the key to a successful beginning of a muting cycle. The sensor configuration will then detect that pallet entirely through the light curtain until it clears the 2 sensors, and then the light curtain will re-establish the protective operation. The key to success with this kind of installation is that the crossover point is on the danger side of the light curtain. I think it's pretty obvious. You can see that someone could step on that crossover point, trigger both sensors, and get into the hazardous area. And that, in a nutshell, describes the strengths and weaknesses of muting systems as they exist today. What I'd like to talk about and show you 3 examples of are some innovations in the field of muting and access protection. But we have to bear in mind, standards define the requirements of a safety-related control system. They do not define state-of-the-art. Standards are always, by definition, behind the technology curve. And within the standard, it's quite explicit. They do not limit innovation in any sense of the word. We pertain towards technical advances. So I want you to keep that in mind when you see some of these solutions. They do actually all meet the standards defined requirements for muting applications, although it might not be obvious how they do that. The first one is using a slightly different technology to a safety light curtain. It's using safe LiDAR technology. And safe LiDAR has the advantage that it's a proximity safety device. It scans an area and detects the environment around it. So using 2 of these devices mounted in a vertical plane, we can create a virtual safety barrier. Because it's a proximity device, we can open that barrier into a silhouette format and allow various shaped objects to move into and out of the hazardous area. The muting is actually executed by having these areas of interest indicated by these blue zones. LiDAR has multiple channels, so we can tell it to look at specific areas of, in this case, a car, but it could be an AGV with a load, an AGV without a load. or parallel conveyors running side by side, which are sequentially letting objects in on one conveyor and out on another, we can use these areas of interest to identify the objects we're looking at whilst differentiating between a person. It's very hard for an operator to walk up to that system and trigger those blue areas of interest, mainly because they can't see them, they're invisible. Don't be under the illusion that if you install this, you have a red curtain. So some of the benefits are that you can create a tunnel according to the dimensions of the materials going through the system. Another advantage is that we can protect against side access. So you can see that anyone trying to walk down the side of that vehicle will also be detected by the residual protection zone of the LiDARs. It can detect irregular shaped objects moving through because you can freely configure the size of these blue areas of interest to pick up irregular shaped objects. And the installation is, believe me, a lot simpler than a light curtain and an array of sensors to pick up an AGV or a vehicle body in production. And out of the box, the solution is certified by a third party along with the PLC functional program that goes with it. Looking at another solution that uses an innovative approach to entry-exit is back to a light curtain, but this time using a technology or algorithm within the light curtain that uses pattern recognition. The way the principle operates is the light curtain is in a horizontal orientation, and as the profile of in this case it's a skid that's carrying a car body, as it moves into the light curtain, it presents a fixed, regular pattern that the light curtain can monitor through the entire length as the car travels through the light curtain. If a person walks alongside or through the light curtain, by virtue of their legs moving together and apart, this is an irregular pattern and is illegal according to the algorithm of the light curtain. So this can also be used with pallets. If you imagine a pallet has a block pattern on the pallet itself, this will, as it moves through the light curtain, show the algorithm a fixed, regular pattern, whereas someone walking alongside the pallet will disrupt it and cause a trip. Now, the benefits of this system is that actually it's a contradiction to the whole presentation because it doesn't actually mute at all. It's always active. It merely recognizes patterns moving through the entire length of the light curtain and looking only for pattern disruption. So the system remains active in terms of protection at all times. Again, it could be used to protect for side entrance or side access if you've got a wide opening and a narrow object coming out of the access point. It's able to detect irregular patterns. So if you've got a pallet block pattern which is 3 blocks, or a pattern which has a 5-block pattern, the system can automatically adapt online to that situation. The other benefit is installation is very simple. It's just a light curtain. You've just got to mount it horizontally, line it up, and configure the pattern limitations that you choose to put into the light curtain. Otherwise, it's push to go. Out of the box, this pattern recognition is certified, so don't feel vulnerable that you're using a novel technology that hasn't been overseen by a notified body. And my final example of an innovation in entry-exit is looking more at small items going through a packaging machine or box erector. Typically, we would guard these access points to prevent reach-in of an operator using a physical tunnel. And a physical tunnel depends on the size of the opening, how far the tunnel extends beyond the machine limit. Typically, a minimum of 800 millimeters length to stop someone putting their arm into a machine would be the requirement. What we've found very recently in the last couple of years is there are more and more applications with smart packaging machines, with courier express parcels, where they want operators in close proximity to the machine, and these tunnels are not an ideal solution to have in that environment. With this, we've come up with another light curtain solution, which is light pattern recognition, but it's looking at profiles. The light curtain can be mounted in the vertical orientation. And with this, we're looking at a profile monitoring approach. And this is that so long as whatever interrupts the light curtain is rectangular, it will traverse into and out of a hazardous area. To achieve this, you would mount the light curtain so that the bottom beam is just above the conveyor bed. And as soon as the bottom beam is broken by anything coming into or out of the machine, it will automatically memorize the beam width or height of the box and monitor that and make sure it's constant during its entire exit. Any part of the light curtain which isn't obscured by the box will remain active, so it's partially muted. You can't reach in while a box is coming out. You can see by the graphics below the profiles that the light curtain will allow through, and of course those sort of profiles that it will not allow through. It's a very specific application, so it suits drums, either standing drums, horizontal drums, or reels, boxes, but not erratic shaped objects. So the benefits is, with classic muting, which I showed you at the beginning of the presentation with muting sensors, it's very hard to achieve this kind of application and differentiate between people's arms and limbs reaching into a machine. Only part of the light curtain is muted at any time. It's very simple to install, and it saves space. Again, it's a certified solution out of the box. So I hope I showed you 3 true innovations in access protection. If you'd like to know any more, then please come to our stand 75, I believe it's on the slide, and we'd be happy to talk to you about any applications on access guarding you may have. Thanks very much for your time.